All right, all right. Hello, GM. I'm already seeing people in the comments in YouTube. Hi to everybody. Welcome to the Alchemy University Student Presentations live stream. This is the first time we're doing one of these, so we may have some technical difficulties as we sort things out. So please bear us and let me know in the chat if you're seeing me and you're hearing me successfully. We're going to be bringing some folks on and yeah, please bear us with that for that. Cool. People can hear me. Okay, great. Quality is perfect. I'm gonna try this feature out on StreamYard. I can actually show comments. Lacho Macchiato. Thank you. Thanks for the confirmation, Nico. Awesome. Great. Okay, cool. So I'm gonna try adding my teammate Dan to this.
I think that might be a little bit easier here because you guys can
hear Dan. Dan might be.
Yeah, I'll send it to you guys.
He's going to be bringing on some of the students who have completed projects.
That'll be a little bit easier. I'll send it to you.
Yeah, it is a little bit dark in my room. It's early in the morning, and I'm in a studio apartment, and I have roommates who are still sleeping. So that's the SF life. Albert Bai, how are you? Pandit, nice to meet you on YouTube. All right. Okay, so hold on real quick. I was testing things out with Dan. Dan, can you hear me?
Yeah, I can hear you. Can you hear me?
Dan can hear me. I can't hear Dan.
Okay. Hold on
what am I doing wrong here?
No, I think it's me.
Can you all hear Dan? Leave some comments so you can hear Dan. If you can hear Dan, then that's good. And then I'll figure out what's going on my end.
Anyone can hear me?
There's Nelson. Hi, Dan.
Oh, cool.
Nice.
Okay, sweet.
All right. Nelson.
Okay, a few people can hear me.
Okay, cool. Yeah, it's just me then. All right. Okay, cool. What I'm going to do is I will add everyone. We have Nelson joining the stream. Nelson and John, and then y'all can chat here for a bit. And Dan, if you want to do some more intro on what the session is about, I'll figure out my personal technical difficulties.
Yeah, absolutely. Cool. So hopefully Albert will be able to hear us soon. In the meantime, he's just trusting that I'm actually talking and not lip syncing here, I suppose, which is kind of funny. So what we're going to do here is we have John and Nelson, who are nice enough to come and present their week 1 projects. Both of them worked really, really hard on the week 1 projects and did an awesome job. So we wanted to really highlight them, and we're going to be trying to do this week to week, where we're going to be highlighting people's projects and be able to talk through some of the different trade-offs of the week 1 projects. So the week 1 project, for all of you who saw it and kind of worked through it, the idea behind this project is to get familiar with public key cryptography, to use this idea of digitally signing a message and having a server verify or recover your address and then be able to see that that message was authenticated by you. Public key cryptography is an interesting technology in that it underlies so much of the benefit that we actually get from blockchains. When we have this ability to be able to do authentication by just having one person own a private key and then be able to then authenticate on a server, we don't have to have this like password protected one set of passwords like we typically do in a client server architecture. The public key cryptography is really a huge heavy lifter behind the scenes for blockchains. And that's one thing that we really want to sort of exhibit here with these presentations. So Albert, can you hear now? No? Oh, no. Okay. Hopefully Albert will be able to hear us soon. What I'm going to do is I'm going to send over to
all right. I'm still figuring things out on my end. I checked the live stream and I can hear Dan through the live stream and I can see all the chat and everything, but I can't hear it through the StreamYard app. So Dan, I know you didn't want to do this, but you might have to do some admin stuff on the StreamYard app. Hopefully. Oh yeah, that's a good idea. All right. Okay, sorry, can you hear me?
Yeah.
Okay.
Let's see. So me and Albert are going to enter a private call, and I'm going to see if I can turn you off over here. I don't know what will work. So you can actually hear me now, right?
I can hear you now, and then you can hear me through StreamYard, and I guess you're muting the call.
Yeah, that works.
Yeah, okay. Okay, sweet. So I think if that's working, then this is good. The setup's good. We have Artsac, John, just rejoined, and Nelson is in the call as well. Yeah, I missed part of the intro, but at this point, do you want to? Is there anything you want to show on screen? I can help with like presentation stuff at this point.
Sorry, Albert. There's a huge echo coming through. I don't think you can hear it, but I'm trying to figure out how to mute you on Slack here in the conversation that we have, so we don't have a huge echo. Yeah, maybe
headphones.
Maybe you can. Yeah. Give me 1 second, Matt. Sorry, everybody, for the technical difficulties. We'll get it straightened momentarily. Okay.
All right. Is that better?
Yeah. Can everyone hear Albert without echo and hear me without echo? I think that's probably good. Okay. Sweet. Okay, cool. So thank you so much, John and Nelson, for joining us. So what we're going to go ahead and do is we're going to have John start off by presenting their application. So John, whenever you're ready, you can take it away, screen share. I don't know, Albert, do you have to give presentation rights to do that?
1 second, please.
Let's see. Do you see, Dan, do you see the present or the menu bar at the bottom right now?
The echo is
Mute,
bad.
stop, spam settings, present, right? Or is it just me?
You can't hear John, Albert.
Well, okay. Can you see the menu bar, Dan? Because if you can, then I think maybe everyone else can as well.
Yeah, I can see it. So John, can you see the menu bar at the bottom with the present button? You could probably take over there and press present and then go to share screen.
You're talking with me?
Yeah. Do you see the menu bar down at the bottom there?
Yeah. I will share it. 1 second. Okay. Guess here. Are you guys seeing it?
No, we're not seeing anything.
I think I'm presenting it.
Oh, interesting.
It at least appears to me as if I'm presenting it.
Yeah, somebody is asking Albert if you could potentially join from a different account so you can hear us and maybe just keep it muted on this one. John is trying to present but can't seem to share screen. I don't know. Here, let me give it a try on mine. Let me see if you guys can see my screen. So if I do something like this, can you see my screen now, John?
No, I can.
You can or can't?
Can't. I can't.
Can't. Okay. How about now?
Yeah, now I can.
Okay. So I think you should be able to do it as well. You should be able to go to present and then share screen. And then I think there's something that comes up that says like, yeah, there you go. Awesome.
Oh, okay.
Now you have it. Cool. Okay, John, it's all you. You can take it away now.
Okay, so let me just refresh it. Here's the app. It's quite simple. The UI is not really good. So here we have the code, and I'm running both the server and the client. I have all these accounts here, and I'm gonna do a simple demonstration of what a transfer should look like. So I added these values here, which is a private key, but it's actually the same private key that appears on the Alchemy cards. So it's like everyone who's seen this live stream already has access to it. So first, if I put here, it appears automatically, the balance, and all of these 3 input camps are connected, so I can do this in any of them. I can do 0x1, and just this. After it, we have the send amount, pretty simple, but 10 in this case. Private key, it has to be the private key of this address. In this case, it's this one. I put in the incognito mode and password mode, so it's, you can see it. And the recipient, we're gonna make this one, and you can see at the bottom that the signature already appears here. So recovery bit 0, signature, this one, and we can go ready and click transfer, and yeah, it should pop up here, and the 0x1 that was 100, now it's 110. I implemented the transactions so that the signature only works on once. This is probably some UI error that's happening right here. So yeah, that's it basically. Let me
Awesome.
just refresh it. Yeah.
Great. Thanks so much, John. Can I ask you a few questions?
Yeah, sure.
So I guess the first question that I have for you for the transactions, is that something that is a field that is getting put into your signature? Are you putting that number in there somewhere?
Yeah. Let me get here. So we have both in the sign one. I made actually the get signature module for everyone, like available in the app, and it passes a parameter here to the other components. What this does is it gets all these values that are already here, and first of all, it checks if all the values are already have, like, they aren't undefined, because if they do, it's gonna just pop up a bunch of errors in the system. So it checks if the values aren't undefined. After that, if the values aren't undefined, he gets the signature, and this passes up to document, which it's pretty basic. Here we have the hash message, the same one in the Alchemy cards, and the document consists of the sender, the amount, the ID, and the recipient. The idea behind the ID is that as the ID is part of the hash, you can only use the hash once, because when we get here into the index and we kind of have to hash our own message to check if the hashes are the same, we check here, one second, document here, we have the ID, and we get from the transactions part that records every transaction, and as soon as a transaction is complete, it adds this one to the transaction. So yeah, it is part of it.
Awesome. Thank you, John. So that was really subtle what John just explained there. I don't know if everyone caught onto it, but the idea behind this ID that John is putting in there is that now, so, okay, what does the ID protect against? Maybe that's the question that I'll pose to everyone in the comments. Can anyone think of something that could go wrong with John's project if he didn't have that ID, that unique ID for every transaction? What could potentially go wrong? Can anyone think of it? What the issue would be? He could sign the transaction in that document. So I don't know, John, can you go back to showing that document there?
Sure. So yeah, which document?
There's a function called document.
Oh yeah, here.
Yeah, so can you zoom in a little bit, John? You could do like a control plus or command plus, and we'll bring it up a little.
My keyboard is 60%, so it's kind of hard.
No worries. Here. Hey, okay, cool. I don't know if I'm saying your name correctly, Matrai. Sorry if I'm saying totally butchering your name, but Matrai got the idea right exactly, which is a duplicate transaction. So what John is protecting against here, which is really, really subtle, is that what you could do is if he took that ID out, John, do you mind commenting out line 31 right there?
Sure.
Just so people know what we're talking about. So he could technically complete his project without that ID, but the fact that he has that ID in there, what could happen is John could sign something from the client side that could say, hey, I'm authenticating with this private key that I want to move funds from me to someone else. And the server could check, yes, that person authenticated it. But what if somebody was able to then replay that signature? They were able to get that signature later and pretend to also then be John, right? If they got a hold of the signature, then they could say, hey, I'm John, and I am trying to move funds from this account to this account, and they could replay that signature. What this ID does, which is typically referred to as a nonce in like when we're doing blockchain transactions, we typically call it a nonce, or a number only used once. What it does is it makes it so that you can only do that transaction once, and we're only going to be able to apply the state changes of that transaction once. If somebody tries to replay our transactions, because remember, on blockchain networks, transactions are public. So if somebody tries to replay that public transaction later with our signature, the blockchain network will not allow it. That's a really, really important thing there. John, is there anything that you wanted to add to that? Is that what your intention was for the ID there?
Yeah, so basically what I try to do is that any data that's crucial wouldn't get sent to the server. Because, like, as you can see, you really have to recipient private key. You have to pass the private key here, but because like in this project, I think it's unavoidable. But I try to do is that every data that's essential to like an attack wouldn't get passed to the server. Because if you see here, the only data that's passed to the server is the sender, the recipient, the amount, the signature, and the recovery bit. So if we didn't have the ID, these two parts would like be essential to an attack. You could just replay the transaction how many times you want until the wallet is drained. So that's not good. But with the ID, you can only use the transaction once, because after you do it, the ID is increased.
Awesome. Thanks, John. John, I have a question for you. If this application was deployed live and it was just somebody else's application, would you ever put your private key into the browser if somebody asked you to?
Yeah.
Why not? Why
I
wouldn't you?
wouldn't, because I mean, I could just make a simple thing here that every time the private key changes, I send it to my personal server and it's stored there. And using a library like FDS, I think, I don't know if that's the correct name, I could just pass to the lists of changes and test every single one if it's a valid private key. And if it is, I could just like straight up test in the code if it has any funds, and if so, I could just steal them. So not good. I only commented this year because, as I said, it's in the Alchemy course, and actually I got the idea of like replay transactions from the Alchemy because it says right here in this part that like it questions you if someone got intercepted a valid signature, would they be able to replay it? So I thought, yeah, they would. So yeah.
Awesome. I'm glad that prompted you to think about that. Okay, very cool. Thank you so much. Does anyone have any other questions for John before we allow Nelson to present as well? Oh, so Matrai asked if we can use a .env file for data, like to store private key. Yes, you absolutely can. Just be careful here that you don't commit your .env up to, GitHub, source control, somewhere else.
Add it to the git ignore.
Add it to the git ignore.
Yeah, I just didn't, because if this was deployed like to the internet, you couldn't really, change the .iv. So I tried to make like a setup that more internet available, like if this was an actual website. But yeah, you totally could.
Awesome. Yeah, be careful, guys. If you ever put your private key anywhere on the internet, even if it's like, in some random obscure place, just consider it compromised. Move all funds out of it if you can, if you have time to. But there are bots that literally troll GitHub repositories. They troll like the entire web looking for things that look like private keys. And if there's any funds in there, they're going to take it out immediately. So be really, really careful about that. I've seen it happen. It's not pretty.
Yeah, even like in a personal file, like a file that's offline, you shouldn't put your private key in it, because like even keyloggers exist. Like you might have a malware that has a keylogger. So generally, the best practice is to just use a hardware wallet, a cold wallet, so that you don't have like to input your MetaMask keys every time.
Absolutely. There's a good question that we're getting from the audience too, which, hey, Nico, good to see you out there, which is how does MetaMask protect private keys in the browser extension? Is that somehow encapsulated? How can we be sure that MetaMask cannot access the keys themselves? MetaMask actually has your private key. It holds your private key unless you're using MetaMask through a hardware wallet, which is what John just mentioned. That would be my recommended way to store funds on a public network or on a live network, is to use a hardware wallet, because then all of your funds, the private key generated is encapsulated in one device, right? So you just have to think about keeping that device secure. Whereas for MetaMask, it's true that the browser extension actually has access to your private keys. If you're just using MetaMask without using it through a hardware wallet, it has access to your private keys. It's keeping it safe. MetaMask is not going to give the private key to the client application. So the developer cannot ask MetaMask, hey, what's this user's private key? MetaMask will not tell the application the private key. The application has no access to it, because if it did, that would be very insecure. So MetaMask is acting as your sort of gatekeeper there. What MetaMask is going to hand off is it's going to hand off the signature. And the signature, as long as we bake in an ID or a nonce like John did here, we can broadcast that signature to a public network and know that we're authenticated through public key cryptography, and also know that there's replay protection in there from the nonce. So really great question. Awesome, everybody. Cool. Well, thank you so much, John. Can we hear some from the comments there? Alchemy says, MetaMask is an extension of your browser, which is local to your computer. It will not hand off the private key to your applications, only your signature. Perfect highlight. Okay.
Yeah, but while it won't, it technically could, right? Like if someone from inside MetaMask want to steal out the private keys, that they could. We just trust that they don't, which is totally the opposite of blockchain. You just create a trustless system.
Yeah, John's a skeptic, which I appreciate. But John, I'll go one step further on you there. You say hardware wallet's the most protected thing too, but then we're trusting the hardware wallet, right? Aren't we? So you're always trusting something.
I actually did something pretty crazy one day. I just got a dice and generated, without any kind of software, my own private key. So inscribed it in a paper so that, now pretty sure no one can access it.
Wow.
Yeah. So
that
would be the safest way. And I actually heard Vitalik, when he had this crazy amount of Shiba Inu that he had, because the Shiba Inu founder sent it to him. They send to the most private key that he has, because if I remember correctly, one part of the private key is with his family. I think it's Canada, Russia, or something, and the other part is with him. So he had to call his family and to then say the private key. So yeah, this would technically be the safest way to ensure that no one cracks it.
Yeah, I heard on a podcast, I forget which one that was, but he was saying that he had to fly somewhere. He had to talk to a couple family members just to generate his private key.
Yeah, I heard it in the same place probably.
The really interesting thing about a private key, Andreas Antonopoulos says this, you could generate a private key by just taking a coin and flipping it 256 times. If you really want to be super secure, don't touch anything, it's you could generate your own private key. You'd have to figure out how to do signatures on your, you'd have to build your own device for doing signatures and all of that. So at some point, it becomes really just helpful to trust something like a hardware wallet or MetaMask. But you could generate your private key. It's just 256 ones and zeros. So you could just flip a coin, heads or tails. Heads put 1, tails put 0, and that could be your private key, right? But you have to be really careful about that, where you're storing it and how you're using it.
And technically, like, to generate your addresses and all of this, you could just get a piece of paper and start doing some math to generate your signature, all of that stuff. Yeah, just start doing some math.
Awesome. Thanks so much, John. So we're going to move over to Nelson to present. Everybody give some love for John. John is a crypto OG there, really like thinking about the private key from the get-go, making sure that you're trusting as few layers as possible, right? Make sure to be really careful with your private keys. And yeah, let's go, John. Awesome work. Okay, Nelson, it is all on you to present your project now. Nelson, whenever you're ready.
Okay. I will start. Well done, John, by the way.
So Nelson, there's like a present button. I don't know if you see it.
Yes.
Okay.
Okay.
Oh, perfect.
Just perfect. Okay, so here my application basic. How does it work? First, you need to generate some public and private key. I already done it and put everything here, so we get our coin. And after, to send a transaction, you need to come use this script. You put the from, the to, the amount, and you generate the signature and the recovery bit. You put the to address. Since I don't, at the first time I had on the server side, I don't know how to get to compare the public address and the public key. So you need to send the public key of the person. Here. And then you can transfer. Oh, no. Oh, yes. Forget the recipient. And then. Oh, no. Made a mistake. Sending. Not the best way, but I've put everything on a text file.
Awesome.
Signature. Recover a bit. And Hammond. Oh.
So that's okay, Nelson. I don't want to have you have to debug live. I took a look.
Sorry.
No. Please stay on your code for a moment. I do want to like highlight some stuff because you took a different approach here than John, which is really, really important to see. Now, I have a question for you guys. Do you guys notice, John, can you scroll over to your UI? Or sorry, Nelson, can you scroll over to your UI for a second?
Yes.
Can anyone tell me why it's a little bit trickier for Nelson to do this than for John? Like, what is more difficult about Nelson's UI here that's making it harder for him to do this without an error? Can anyone notice like the big difference between these two approaches? So what is, or maybe a better question is, what is the difference between the approaches? What is Nelson doing differently here than what John did in this project? they went about this 2 different ways, which is really, really cool. And so we get to highlight this in 2 different ways. Yeah. Yep. So Arjun pointed out here that he can just generate the signature, right? So what is happening in Nelson's that's a little bit different from John's is that he is generating the signature not inside of the application. So John is actually showing off something here that's a little bit less user-friendly, right? We can't put the private key in here. The tough thing about this project is we didn't have you guys connecting to MetaMask or a wallet or anything like that, right? So it becomes much more difficult where you're actually doing the relaying of the signature. So something that John is trying to, Nelson is trying to do here that is making things a little bit more tricky is he's trying to generate the signature offline and then post that into the web application. What is the big advantage to this approach? We could see that it's a little bit harder to do this one, right? It was much easier to go through it from a UI perspective with how John walked through it. What is the advantage of this one versus the first one? What would you guys say? So the advantage here, and John had pointed this out, is that we're not putting the private key. Oh, well, you do have the private key on the wallet side. That's true. But
yes, it's just to show the balance, but we can put the public key if we prefer.
Right. On the send transaction side, you don't need to put the private key in, right? Is that correct?
Right.
There, Nelson?
Yeah, yes, exactly.
So
It's to make a hardware wallet to sign the transaction offline and after put everything to send the transaction.
Exactly. Yeah. So a big difference here, right, is that because Nelson is taking the signature and pasting it into the application, the only thing the application gets is the signature. And the signature is not something we need to be concerned about. The signature is something that you just broadcast to Ethereum nodes, you broadcast it to JSON RPC providers, and you say, here's my signature. Please do my transaction. And at some point, that transaction is going to go through many mempools. It's going to live in many different places across many different nodes. And one of those nodes eventually is going to get the right to build the block. And when it builds the block, your transaction may be included at that time, in which case your transaction is then going to get applied once and can never get applied again. So the really cool thing that Nelson is doing is the send transaction. There's nothing here that could compromise you on that side of the UI, right? So this made it a little bit trickier, but it is a different approach to solving this. And when we compare this to something like MetaMask, this one is a little bit more like what you would expect with MetaMask, where MetaMask is going to do the signing, and then it's going to broadcast the signature to a JSON RPC provider, to a Ethereum node somewhere. And that Ethereum node is then going to gossip that transaction out to all of its peers. And eventually somebody will then build that block and have your transaction in. Cool. Is there anything you want to add to that, Nelson?
No, nothing in particular. We can we can check everything on the server side if I regenerate, I get the sender, the recipient signature, and just compare the two and check if it's okay.
Awesome. Yeah, so you can see what Nelson's doing here. He is sending through the sender, the recipient, the amount signature. He's recovering the key, right? So he's recovering the public key from the signature, and then he's comparing that against the public key that's sent through. If that's equal, then he says, okay, this is valid. The person who has this public key actually wants this transaction to go through, at which point we can go ahead and send this through. So I have a question for you guys. Exta node, why isn't this a blockchain, right? This project that you guys built, that you worked on for week 1, what is the big difference between this and a blockchain? Could we put this live and call it Nelson chain or John chain? Is this good enough to be a blockchain? What is the difference? Because it tracks accounts and balances. It has public key cryptography. What is the big difference between this and a blockchain? What do you guys think? Nelson or John, do either one of you guys want to take that one?
Oh, I
Uh,
sent it in the YouTube chat. It's because it's centralized.
Exactly. It's centralized. 100%. That's the big difference, right? Otherwise, this could be a blockchain, right? It's got the same features. You could build in account balances. Maybe you could even build in smart contracts. But the difference is it's only one node, right? You don't have many nodes in this network that are communicating and building a consensus of what the state should be. But this is one node of a blockchain. So you could think of it that way. What is the one thing that we're trusting the server not to do in this case? The server is verifying the public keys and it is moving the balances from one account to the other. But what are we trusting the server not to do here?
Yeah, so I mean, I'm hosting the server. I could just get on my admin console and just send a billion coins to my wallet and then just dump it out on the market.
Exactly. Yeah, we're trusting you not to move the funds from your account to the other, right? That's the big thing that we get from blockchains, that we get from consensus, is that we can then have a bunch of nodes that agree upon the state. Now, in a blockchain, what do you guys think is stopping one individual node in a blockchain from changing the account balances? Let's say like John or Nelson is running an Ethereum node or running a Bitcoin node. What's stopping them from just changing the database value inside of their local database and getting more Ether or getting more Bitcoin? Like, why is that not helpful to them? Why can't they just do that if they're running a node?
Could you repeat the question, please?
Yeah, it's a bit of a tricky one. So I'm trying to come up with the simplest way of asking the question. But the question is, okay, so what you just showed us is like one node in a blockchain network, what you guys just built, right? We could see inside of your node that you could just change balances, and we're trusting you not to do that. In a blockchain network like Ethereum or Bitcoin, what's stopping you from changing those database values on
The
your local node?
consensus mechanism.
Exactly. That's right. So you can actually, with an Ethereum node or a Bitcoin node, you could write the code. You could download Bitcoin source code. You could download Ethereum source code. You could change the database values on your local node, but nobody's going to agree with you. Nobody's going to agree that that's the state of the network. You could change it. You could say, hey, I have 1 million Ether, and you could live with a local state where you're, a millionaire in Ether, but nobody's going to believe you. What enforces that is the consensus mechanism. You have to obey the protocol rules, which say that you only get to mine in certain circumstances, and you can only mine transactions that follow a specific rule. And that rule is things like in Bitcoin, you can only spend UTXOs that you have the unlocking script for, which you guys will learn about UTXOs this week. In Ethereum, that's like you can only send Ether that you actually own. If your account balance is less than the amount that you're trying to send, you can't send that amount. Those kind of rules are enforced by consensus protocol rules. And so this is what we're going to be diving into this next week as it's coming up because of the consensus mechanism. Awesome. You guys are all getting it. That's great. Cool. Well, this was super productive. Thank you both, Nelson and John. Does anyone have any final questions that we want to try to highlight here? Anything you could think of about blockchain from week one? See if we can. I see what's a UTXO. So that's a good question, actually. What's a UTXO is the next thing that you will learn in week 2 of the Ethereum Developer Bootcamp. So that's actually what's coming out. We are at 12:45 my local time, Eastern. The content will be live in 15 minutes, at which point you can answer that question for yourself by go checking it out in week 2 of the Ethereum Developer Bootcamp, and you will learn what a UTXO is, and you can compare that to the Ethereum account model. Bitcoin uses the UTXO model, Ethereum uses the account model, and you'll see the differences between these two and understand why they chose these different models and what the trade-offs are, because it's always sort of a trade-off discussion in a lot of these types of things. Cool. And Nico says, is it strictly necessary to hash the message transaction before signing? Yeah, that's a really good question. Is it strictly necessary to hash the message transaction before signing? I think that yes. I think that there is actually so this is this has to do with what public key cryptography mechanism you're using to sign the message. But I do believe that public key cryptography, and you guys will have to check me on this one, exta cryptography or elliptic curve public key cryptography, you can only sign messages of a certain size and still have security baked into it. I think if you have a certain size and you're trying to sign a message, let's say it's like over 500, let's say it's over 512 bits, I think you lose security there. There's actually some like security concerns. So elliptic curve cryptography is actually all built on the assumption that you're going to be signing a message of a certain size. So what's really nice there is that with a hash, what we could do is we can hash anything of any size, right? We could hash like a book, we can hash a video, and we're always going to get a fixed size output. And then we can put that through public key cryptography. And public key cryptography is guaranteed to work under those conditions. But if it's bigger than that, I don't think those security properties hold any longer. So yeah, really good question. That's something that I'd love to toss some more resources in there, but I do believe you'll have to ask some cryptographers there. But that's how public key cryptography is set up to work, is only for messages of a certain size. Great question. Hey, Dan, want to know how centralized exchanges handles our private key? John, I think you could answer this question. John, do you want to say how centralized exchanges handle?
Yeah, so centralized exchanges, they usually just have one private key per, like, you can actually check if you see the list of the wallets that use the most gas. You will see like the Binance wallet, all of those, the Coinbase wallet, all of those big wallets there. So all of your investments are like all of your data, like how many Bitcoins you have, how many Ethereum you have, it's just all under systems. So it's not really secure at all. You can see what happened at FTX like a few weeks ago to just see that. They just decided not to give money anymore. And they did it. And SBF is out there walking free. So yeah, that's it. I guess Binance for some blockchains gives you a wallet, like in a specific wallet, but the private keys with them, you don't have access to the private key. You just send a request to make a transaction, and their system handles it.
Yeah, that's a really good way of explaining it. And I mean, if you want to see, fumbles of private keys from centralized exchanges, just go read about the Mt. Gox hack. The guy who was running Mt. Gox just had private keys written down on pieces of paper in his desk, and that's how he was managing a lot of the Mt. Gox funds. So how do private keys handle, or how do centralized exchanges handle their private keys? It's really up to them to figure out the best security around it, right? So I mean, John's answer really highlights this. You're trusting them to figure out good private key management, and however they choose to do it, that's how they do it. They don't need to necessarily have one private key for every user, right? You could send them some funds, and what they could do is they could pool that together with everyone else's funds managed by one private key, right? And you're just trusting that whatever infrastructure that they build with that is going to be safe. And for some centralized exchanges, I think they've proven with a good track record that they can keep funds safe to a certain degree. But just know that that's what you're trusting. You're trusting that they're going to keep your funds safe and that they're going to stay solvent. So yeah, great question. Awesome. When are we learning the new proof of stake consensus? That's a really good question. We want to write some really good materials on proof of stake consensus. What we'll do, because I know this is something that we're lacking on, we will send you guys some resources, and we'll try to get some more into the course soon. We don't actually have any plans for teaching proof of stake just yet, just because it's been like an evolving thing for Ethereum. So we wanted to give it some time before we started teaching proof of stake. Proof of work is a much, much simpler consensus mechanism. That's why we like to focus on proof of work first, because you could learn proof of work within a day, right? You could understand the idea of proof of work. It's a very, very simple and elegant mechanism. The idea that you can just keep hashing a message until you find something with a certain amount of zeros or below a certain target difficulty, like that's a really elegant mechanism. And the whole idea of following the chain that is the longest blockchain is an amazingly simple rule. Something that I would suggest you guys do now that you've completed week 1 blockchain Ethereum developer bootcamp is go read the Bitcoin white paper, because in the Bitcoin white paper, you're going to really just see how simple Bitcoin is from a high level, right? There's just 8 pages that describe everything about Bitcoin that was just written by an anonymous author back in, was now it's slipping my mind, 2008 into 2009, right? So you could see how simple this concept was and how well it was executed upon. You could just the biggest problem was we were talking about this idea of a consensus mechanism, right? And what stops people from changing the database values in their local node is this idea of a consensus mechanism. Consensus mechanisms are difficult to come up with because you have to get everyone to agree on one common state. So then you have to come up with a bunch of rules that say, these are the ways that you can change that state. For proof of work, it's really, really elegant. The way that we know what the main state is it's the one that has the most work done on it. Because then we know that's where most computers are focusing their resources. So you can ask me, Dan, did you send me that Bitcoin? And you could go look up on the Bitcoin blockchain to see what is the source of truth? What is the longest blockchain, the one that most of the computers are focused on? And you could get a feel for what is the truth of the Bitcoin network at any given time. What is the finalized state, right? That is the concept behind like Bitcoin's finalization, is it's probabilistically finalized in the sense that it becomes harder and harder to change some state from many nodes back. So
Yeah,
definitely check out the Bitcoin white paper.
One thing I actually find really great is that if a blockchain becomes longer than the main chain that's like being built, it just becomes a parallel blockchain. So you can have both coexisting, which is quite fun to think about. That the way we decide which one is the one that we are going to trust is basically, not really just based on our behavioral science, like the way we decide which blockchain is valid, like, and the way we attribute value to the cryptocurrencies and just money in general is like totally fabricated. Like the value of money and it's just taught, not something like real. I don't know if I made myself like clear.
Yeah, it's an interesting concept, like what gives money value, right? Like what is it backed by? And for Bitcoin and Ethereum, that's some of the biggest proponents of Bitcoin and Ethereum is we know what it's backed by, right? We know what keeps the blockchain safe. And that's why a lot of people love it, right? It's such a great technology.
After the Second World War, the dollar wasn't backed anymore by gold, and all the nations that had like a reserve of billions of dollars were actually kind of scammed, because right after the Second World War, they wanted to get the gold back from, like, they had all these dollars and they wanted to get the gold worth of it. So the Federal Reserve just said, well, we won't do that anymore, and they did. So the dollar isn't backed up by anything.
That's right. Yeah, got rid of the gold standard. Yeah. So I mean, that's a big proponent of Bitcoin, right? You know how many there's going to be. Ethereum, there's like a specific schedule for how many Ether there will ever be, whereas for fiat currencies, typically they can inflate it as much as they need to. And there's trade-offs to both sides, right? I mean, we're in a big space of trade-offs. There's definitely trade-offs to fiat currency as well. It's much easier to use. It's integrated into everything that we know. So it's a really cool space that we're in, that we get to explore these trade-offs. And that's something I always want to try to like bring back to, is this idea that much of the things that we're going to be talking about have trade-offs. There was a question that was highlighted too, which is, what is a Merkle tree? I love that question, by the way, because that's the second thing you'll learn this week. I had a question: what is UTXOs? What is Merkle trees? You guys are just asking about all the things that we're about to show you in week 2. So it shows that hopefully this course is following through on a good, a good schedule. So Merkle root, the reason why I wanted to bring the conversation back to this is you guys will also see that this is a space of trade-offs. So when you're looking at these data structures this week, you're going to notice that there's different trade-offs between when you should use a data structure like a Merkle tree and when you should just use maybe a hash, right? And I want you guys to explore those trade-offs, just like we explored the trade-offs between these different projects that John and Nelson showed us today. So with that, what we'll do is we will wrap things up. We have about 5 minutes until the content goes live. So when you guys are ready, get a drink, get something to eat, and then get into that week 2 content. We're super excited for all of you to get in there. And if you guys can give one final thank you to Nelson and John for presenting this week. I would love to see more of you come up here and present your projects in the future. So just know we're always going to put this effort behind the projects. We'd love to see you guys build these things and continue to explore how we can build better applications. So excited to have you guys up on here. Thanks, Nelson. Thanks, John.
Actually, I have a question.
Sure.
Does like the week 1 project will get built on as the weeks progresses, or it's just like a totally new project every week?
Oh, that's a really good question. It's a totally new project every week. However, we do think that, so we'll have a final project at the very end. And we do think that in a lot of cases, you can build on your earlier week's projects. Like this next week's project is going to be about Merkle trees. And a lot of people like to use Merkle trees towards a final project for things like NFT airdrops, things of that nature. But we won't be building on the project week to week. This is pretty much like the final state of it. Yeah, great question.
Okay, thanks.
Awesome. Thanks, everybody. Great. See you all in the Discord. Take care, everybody.
See ya.
See you.